In this video, I introduce a generative context distillation for large language models. Generative context distillation is a prompt internalization method which trains the student large language models to mimic the teacher behavior through the generated prompt content. Assuming that application-specific prompt P is predetermined, the goal of GCD is to guide large language models to behave as if the prompt is given, even in his absence. The teacher model T and the student model S are defined based on whether the prompt P is provided to the same model theta. Context distillation fine-tunes the student to internalize the given prompts into the model parameters. Namely, the optimization objective is defined as here, where xi is the input at turn I, yis and yit are outputs generated by the student and teacher respectively, as shown here. This is a teacher model, this is a student model. GCD fine-tunes the student on multi-turn outputs to understand and mimic the teacher behavior for a given prompt. GCD fine-tunes the student model by a sequence-level knowledge distillation from the teacher model, namely the supervised fine-tuning loss, LSFT, for fine-tuning the student model is defined as here, by which the student model can only learn the prompt through the teacher's output. However, GCD fine-tunes the student model to learn content of the prompt through reasoning. To this end, a prompt generation loss, LPG, is introduced and calculated directly on the prompt, as shown here. The join loss L is defined as here, where lambda is used to balance two losses, LPG and LSFT, as shown here. This prompt generation loss, and this supervised fine-tuning loss. This is a large language model. Minimizing L trains the student to understand the teacher behavior based on the prompt. Assuming that the predetermined prompt has never been encountered before and is not included in any training dataset for prompt internalization. The action in prompt are conducted between the agent and his environment, which means that collecting multi-turn conversation outputs requires interacting with the actual environment at every turn. Self-role-playing conversation involves reversing the role between the agent and the environment, as shown here. A model theta uses the role reversed context to simulate the text environment. By swapping the agent and the environment role in the prompt, the model theta can embody with the agent and the environment, enabling the collection of self-conversational outputs Y. Large language models generate the supervision for the reason R from the prompt, user input X, and outputs YS and YT. The reason explains why the student output showed along with the teacher output. For more details, please check with these references. Thank you. Bye.